Hey guys, and welcome to this video in the algebra series, this one on graphing straight lines. So as you can see there, we're talking about straight lines, only the one type of line for this particular video. We're talking about equations such as y equals mx plus b, which I'm sure you've seen before, and ax plus by equals d, which can be rewritten to look like y equals mx plus b to make things a bit easier for us. So a couple of things to be remembering. We have gradient in terms of our straight lines. Our straight lines always have a gradient. And our gradient is the rise over run. So the gradient is the slope of the line, and it is calculated by using rise over run. Okay, now this is what we mean by this is we calculate the change in the vertical distance, in the vertical coordinates, and put that over the change in the horizontal coordinates. So another way that we can actually write this is in an algebraic format. Okay, we can do this in an algebraic format where we have a lowercase m and we do our change. Alright, so we find that difference and then we find this difference, and that's our rise over run. Okay, you can see in the little diagram there, that's what's happening. Now the other thing that we can refer to this as, and this is very important for those doing advanced maths, it's also the rate of change. Okay. Now in terms of the gradient, we have 4 different types of gradient. You can see the little lines under here. All right, we have the 4 types of gradient. We have what we call a positive gradient. So that's our positive gradient. It's going on an uphill trajectory, so it is going from left to right upwards. So it's an uphill trajectory. We have our zero gradient, which is simply just flat. We have our negative gradient, and our negative gradient, well, it goes from left to right on a downhill trajectory. And then our last one here is undefined. We call it undefined because it doesn't really have a slope. It's just straight up and down, so it's undefined. Okay, now, as we can see at the other diagram, we have a couple of other little points about this. We also have intercepts. We have an x-intercept and a y-intercept. Okay. Alright, so how we find the y-intercept? Well, that is when x equals 0, because that's what the y-axis is. And the same with the x-intercept. That's when y equals 0, because that's the x-axis. So far we've looked at some gradient, we've looked at the intercepts, and now we're going to have a quick look at something that is a little bit more advanced in terms of the gradient that I'm just going to show you. Okay, so in terms of the gradient, we could actually use trigonometry. Okay, So if we're given an angle instead of sides, what we can do is we can use our trigonometry. Okay, so gradient can also be written as our lowercase m equals tan theta. And it's as simple as that. So we have, remembering that our tan theta equals opposite over adjacent, and we will be revisiting these concepts at some point. But that's essentially what it is. The opposite is the rise, and the adjacent is simply the run. So that's just another way to approach these problems. Okay. Don't need to worry too much about it. You just need to know it exists at this point. Alright. Now, remembering a couple of little facts about this stuff, we will probably visit this a little bit more at another date. Okay. What we use is the gradient intercept form. Most of the time for the equation. And that is the y equals mx plus b. Okay, so one of the things, so here is our y coordinate. Okay, we have our gradient. This one is our x coordinate. And then our last one there, that is the y-intercept. So you can see there, the big bits of information are going to be the gradient and the intercept, hence the name gradient intercept form. Now you can see one last diagram there that we need to have a quick chat about. So there are some special lines, so we can have a horizontal line. All right, so the horizontal line is this one here. Okay, and that's just whatever the y value is. So that is the horizontal line, y equals b, so whatever the y-intercept is, that is our equation, y equals b, and it's just a straight flat line, so it has a gradient of 0. And I'll just pop that in there as well. 0 gradient. You can see there we also have a vertical line. Okay, we have our vertical line here. And this one is x equals k. So we use a different letter to represent where it's crossing the x axis. But this is our vertical line and it is x equals k. And then our last one there is anything crossing through the origin doesn't have a specified y-intercept because the y-intercept is 0. So this is our through the origin. So line through the origin. Okay. Okay, since there's a whole bunch of examples to go through, we're going to put those examples in the next video.